Hey guys, welcome back to Genius Learning. So I want to continue on this example and move on to the same setup, but instead of the box going upward because of a force, now we're going to say that the box starts here and then starts sliding downward at a moment later. So we place the box down and it starts sliding down the ramp. Okay, so what are the forces on the box? And how can we calculate the acceleration or friction using Newton's second law? So first, let's identify a graph that we can follow on this problem. And so a graph meaning the X and Y axis. And we want to do, so this time, I'm going to label the Y still going up, right? That's perpendicular to this plane. But this time, I want to say that going downward is going to be the positive X. And remember, you can choose positive or negative going down or up depending on the conditions of your problem. So downward, I want to say it's positive, and upward now is going to be negative. Okay, once we've done that, we've already seen that gravity on any object pulls straight down to the ground. All right, so this here represents the ground. Any object, no matter if it's on a slide or anything, it's gonna go straight down. So this is mg. Okay, we're gonna draw the normal force perpendicular to the surface, and we're gonna draw a vector going in the opposite direction. Okay, and we saw already how this angle is the same as this one. And with that triangle, we can use the components of the gravity. So we can say that adjacent over hypotenuse is mg cosine theta. And then we can draw another triangle that is parallel to this plane. So in this direction here, right? This big triangle here. And we check using this 90-degree angle, right? The farther side is the one with the angle, right? 90 degree, the farther one is the one with the angle. This is the shorter side with no angle. So shorter side, no angle. And so we can use this triangle opposite over hypotenuse, which is mg sine theta. And we can put this vector up here. And so we got mg sine theta. Okay, this and this are the same vector. All right, so now if we have the box starting from this position and then we let it go and it starts sliding down, the direction of friction is going to be opposing its motion, which is upward. So friction always opposes your motion. It wants to slow you down. So if the box is sliding down now, then friction is going up. So this is our friction, okay? And this is our force due to gravity. So gravity is doing its work and just pushing down the box here. Okay, so now let's do Newton's second law. And we're gonna say that the sum of forces, right? Net forces, okay? We know that friction is equal to mu mg cosine, right? Because we already found it in this problem here. And now let's do the forces in the x direction, okay? So the forces in the x direction are going to be in this direction and that direction. So let's start off with the positive first. And remember, this is the positive direction now, because we labeled it that way because we can. So you should choose whichever direction you want, positive or negative. So downward is going to be positive. So we have mg sine theta, which is this one here. And then we have minus the friction. So minus the frictional force equals ma in the x direction. So that's the acceleration in the x. So let's replace this f already with this. And remember that that's how we were able to get our frictional force, is with the force, the net force in the y direction, which was N equal to mg cosine theta. Okay, so, and we found that here, so it's the same process. So now we plug that into the F, and we get mg sine theta minus mu mg cosine theta equals max. All right, so we can use this equation here to solve for things that we need. And in this problem, we can actually get rid of all the masses because we're only dealing with one object, and so all the masses are the same. So we just divide by mass, right? This is mu, which is the coefficient of friction. And so if we rewrite this, now we have acceleration in the x direction is g, we could pull a g out from both of these terms, and we have sine theta minus mu cosine theta. Okay, we could use this and other equations I'm going to show in the further examples. Okay, so that's how we deal with the sliding box on a ramp, upward and downward. And these are the different setups we need to understand. All right.